Okay, we're back again with our Solving Right Triangles series of videos. This is case 2, where we're given the hypotenuse and one of the legs. It really doesn't matter which leg it is. It works pretty much the same whether you're given C and B or C and A. Notice that in the leg case that we did last time, back here, where we're given two of the legs, like say the A and the B here, you could pick any positive number for those lengths and it would work out. There is a triangle. Now, of course, in the hypotenuse leg, the hypotenuse has to be the longer side, and of course if you don't put in a long enough side for C, if it's not longer than A, nothing's going to be, you're going to get some undefined things here and things aren't going to work out. But as long as you pick any length for C that's, say, bigger than what we do for A, let's say 11 here for C and 5 for A, for example, then we can make exactly one triangle of that size. So this is the hypotenuse and a leg, and of course we know the right angle. So this is a case, a special case of the big S, little s, A situation. Okay, so note that relative to the angle B here, okay, which ones are we given? Well, we're given the adjacent leg and the hypotenuse. Adjacent, hypotenuse, that suggests cosine. Cosine of angle B is adjacent over hypotenuse, so that's A over C. So to find angle B, we do the inverse cosine of A over C, and with our particular values of A and C, that's the inverse cosine of 5 over 11. Centimeters are going to cancel out here, so I can take this on my calculator and do, first of all, check my mode. I'm in degree mode, so my answers will come out in degrees. So I do inverse cosine. The answer will be an angle whose cosine is whatever I put inside the parentheses. So 5/11 is the cosine, and this will give us the angle that has that cosine, the acute angle that has that cosine, and that has 62.96430.821 degrees. Okay, so about 63 degrees. And then we can do 90 degrees minus that answer is the easiest way to get angle A. There are other ways to get angle A as well, but that's probably the easiest way, is just to use that. So it's about 27 degrees. Now to get to side B, we use the Pythagorean theorem. Notice that a squared plus b squared equals c squared. So subtract a squared from both sides. B squared equals c squared minus a squared, and square root b equals the square root of c squared minus a squared. So that's square root of 11 squared minus 5 squared. So in the calculator, that's square root of, notice it opens the parentheses, 11 squared minus 5 squared, then close the parentheses. So it does the squaring, then the subtracting, then the square root last, and that gives us our length of our side B, 9.79796 centimeters. Finally, we'll compute the area. It's 1/2 A times B. So that was, let's see, what we just figured out was B. So we want 1/2, 1 divided by 2, times A. A was 5, times B. B was my previous answer, so I can go second answer. Or I could have stored that as B and then pulled it, just type B at this point. And this gives me my other side, gives me the area, 24.49489743 square centimeters. Okay? How about you try one this time? Let's try one where the length of A is 3 and the hypotenuse is 10. A is 3, hypotenuse is 10. Figure that one out and then come back here and check it. Press pause now. Okay, so let's see. A is 3 and C is 10. I think this is the one we want to try. So if you draw it to scale, it looks like this. Again, B is the inverse cosine of A over C. So in our calculator, that's the inverse cosine of 3/10, and that angle is about 72.5 degrees. B then is that's B. 90 degrees minus our answer will be A, 17.458 degrees. And to find side B, a squared plus b squared equals c squared, so b equals the square root of c squared minus a squared. So we want to find side B, we do the square root of c, 10 square, minus a, 3, let's square it, close parentheses, and we see that 9.539. That's B. So we take B times the A and divide by 2 to get the area of about 14.31 square centimeters. Okay, that's that case. Short video. We'll come back for the another series of short videos, one for each case. We've got 2 down and 6 more to go.